Hello students, welcome to Aditya Academy. I am Dr. Dagini Arora and today we are going to start exercise 6.3 from Ncert. In this video, we are going to cover question 1 to question 9. And this exercise is about the concept of similarity that we had learned in the introductory video of this chapter. If you haven't watched that video, I would request you to go into that video. I have explained it in the very basic manner. How can we prove two triangles similar? And what are the different criteria? I am here giving you a recap. Two similar triangles or two triangles can be called similar if they are same in shape and their sizes are proportional, or you can say the sides of those triangles are proportional, right? So they need not be equal in size, their shape should be same, that means their angles should be equal. Their corresponding angle should be equal so that they retain the same shapes. Moreover, their sides have to be proportional. So this is the basic criteria for two triangles to be similar. And we have three different types of similarities. One is SSS similarity, in which the ratio of three sides of one triangle is equal to the ratio of three sides of the second triangle. Next one is SAS. SAS is when the ratio of two sides of two triangles are equal and the included angles are equal. Then they are similar. And the last one is AAA similarity. This is the easiest type of similarity. Even if we are given only two angles equal, the third one automatically becomes equal according to the angle sum property of a triangle. So in this case, we only have to prove that two triangles are, if in two triangles, two angles are equal, we can say that the triangles are similar. So we have these three types of similarities. And one more important thing, I had told you that we should write the corresponding parts of one triangle in the same order as their parts are equal, corresponding parts are equal, so that the accurate order of the triangles are written, so that even if we have to find the corresponding parts, they are always in the same manner, right? So this is the first question. In the given triangles, the following figures are similar. Write the similarity criterion used. So state which pairs of triangles in the following figures are similar. First, we have to check the similarity, and if they are similar, we have to mention the criteria, either it is SSS, SAS, or AAA. Right? So we start with this. Mention the name of the triangles in the beginning. In triangle ABC and triangle PQR. Now check for the corresponding equal parts. If we have angle A here 60 degree, which angle is here 60, which is P. So I can write angle A is equal to angle P, right? Each 60 degree. Then here we have angle B as 80 and Q as 80. So angle B is equal to angle Q, each 80 degrees. Finally, angle C is equal to angle R. Angle C is equal to R, each 40 degree. Right? So if we check, we have three angles of one triangle equal to the three angles of another triangle. So this satisfies this criteria. We can write triangle ABC. I'm explaining here. We had learned this in introductory video. Always write the first one, you can write in any order. But for the second triangle, you have to match the corresponding parts. A is equivalent to P. So A is in the first place, write P here. B is equivalent to Q. B is in the middle, write Q here. Finally, we have C equal to R. So C is the last and R is the last letter in this. So don't try for making an alphabetical order in the names of the triangles. It is always according to the corresponding parts which are equal. So if it is triangle ABC here, it is triangle PQR and it is by AAA similarity, right? Next part is in triangle ABC and triangle PQR. What is given to us? AB is 2. Okay. Then look for, see, AB is 2, BC is 2.5, AC is 3. Look for any particular ratio which is being followed in the sides of triangle. If we check for AB is 2, 6 is 3 times. Then 6 is 3 times. This is 4 is 2 times. So check what we can do. If AB upon AB is 2 and QR is 4, right? If I write AB upon QR, it is 2 by 4. Then if I check for BC, BC is 2.5 and PR here is 5. So if I look for BC upon PR, it is 2.5 by 5. That is also 1 by 2, which is 1 by 2. And finally we have AC is 3 and QR is 6. So AC upon QR is 3 over 6, that is 1 over 2. So I had told you earlier that do not go by the actual location of the sides in a proper order. If 2.5 is here, 5 is placed here. If 2 is here, 4 is there. Don't look for the exact positions in the figure. You just have to look for the proper ratios, right? So what we can do here is, we can see that the ratio of three sides of the first triangle is equal to the ratio of the 3 sides of another triangle. So we can write AB upon QR is equal to BC upon PR. See here. And it is equal to AC upon QR. All of them are equal to the same ratio, which is 1 by 2. So the sides of 3 ratios of one triangle is equal to sides of the 3 ratios of another triangle. So these triangles are similar. But here we have to maintain the names in a proper order. So what shall I write? See here, A is not equivalent to P. How shall I look for the corresponding part? See, I'm telling you a very easy method. Like in these two parts, look for AB, QR, BC, PR. Now in these two numerators, what point is common? If it is a case of SSS, this is the easiest way to locate the point. AB and BC. We have B, which is common to both, right? In the denominators, we have QR and PR. So what letter is common? R is common to both. So that means if we have B in the numerator, so corresponding to B, we have R. B here is in the middle, write R in the middle, right? Now check for, here it is AB, and we have equated B to R. So what is corresponding to A? Corresponding to A, we have Q. So if A is here, write Q. So P automatically goes there, right? Let me explain you once again. When we have to look for the corresponding parts in the case of SSS triangle, it is very easy. You must learn this. From two ratios, check the numerators for a couple of ratio, right? What is the common letter in both the numerators, which is B? Similarly, look for the common letter in the denominators. It is R. So B point is equivalent to R. So B was here in the middle of the A and C. So I have written R in the middle. Now if you look for AB, corresponding to B, we have located R. So B is corresponding to R. That means for A, we have Q. So A is the first letter. I have written Q in the first. So P automatically goes in the last order. This is very important part in similarity of triangles. Now ABC is similar to QRP, not PQR. So this is SSS similarity. If you are not able to locate these sides, which side should be equal to what, always go by this method. You will never do any mistake. Next is we have like LM is 2.7 and okay, what side shall I take? We have MP is 2. Do we have anything 2P? Okay, then DE is corresponding to DE, this is 4. If I take LP as 3, we have DF as 6. So we can see that MP upon DE is 2 by 4, that is 1 by 2. At least two sides are making a proper ratio. LP upon DF is 3 by 6, this is also 1 by 2. But LM is 2.7 and EF is 5. So LM upon EF is 2.7 upon 5, which is not equal to 1 by 2. So we can say that though these two ratios are equal, but the third one is not equal, and neither we are given any angle corresponding to these two equal ratios. So we can say that triangle MLMP or MPL is not similar to triangle DEF. Since neither three ratios are equal, three ratios of the corresponding sides are equal, neither we are given any angle in this figure. So these two triangles are not. Next we have, this question is, next we have triangle, in triangle MNL and triangle PQR. Now see, MN is 2.5 and PQ is 5. So if we check the ratio, MN upon PQ is 2.5 upon 5. Right? Next we have ML as 5 and PR as ML as 5 and QR as 10. ML as 5 and QR 10. So we have ML upon QR is 5 by 10. That is also 1 by 2, which is also 1 by 2. So we can see that MN upon PQ is equal to ML upon QR. Now let us see one thing. We have taken ratio here, like this and this. These two sides corresponding to these two sides, right? So what we have to take care of this, like this angle is 70. When we are taking the side ratio of these two sides, the included angle here is 70 degree. And here we are taking the ratio of these two sides and the included angle here is 70. So this you have to check. Had it been this angle equal to this, these triangles would not have been similar. Right? So this is just exactly similar to when we prove SAS congruency. The angle has to be the included angle. Whenever we are taking the two sides of one triangle, the angle that we are considering should be included in those two sides, which is the case here in both the triangles. So we can say that angle M here is equal to angle Q, each 70 degree. So we can say that triangle, now again write one in any order, MNL is similar to triangle. Now tell me what shall I write. Here one thing is very clear, angle M is equal to Q. So if M is at the first place, write Q here, right? And now let me analyze what should be equated with N. take the numerator mn and check here PQ. We have seen that M is equivalent to Q. If M is equivalent to Q, then N is equivalent to P. So at the place of N is in the middle, write P here, R automatically goes there. Right? So triangle MNL is similar to triangle QPR, and this is called SAS similarity because we have used ratios of two sides and the included angle. Similarity. The next part is we have in triangle ABC and triangle DEF. Now see here AB is 2.5, right, and DF is 5. So AB upon DF is 2.5 upon 5, which is 1/2. Next we have BC as 3 and EF as 6. So BC upon EF is equal to 3/6, that is 1/2. Now see that angle here is A. Here it is angle A 80 degrees, angle F 80 degrees. Now you can see that I had told you earlier, here the ratio is between these two sides and the angle is included in these two sides. But here the ratio is given about these two sides and this angle is not included in these two sides. It is outside. Had it been angle B, then these triangles were similar. But now this 80 is not included in these two sides for which we have taken ratio. So we can say that since angle B is not equal to angle F, here the angle is included. It should always be including the two sides. Here it is not. So B is not equal to F. Therefore, triangle ABC is not similar to triangle DEF. Right? Next part is here in triangle DEF and triangle PQR, we are given as angle D is equal to 70 degree. And in this figure, angle C 70 is not equal to any of these angles. What we can do is angle D is 70, angle E is 80. So angle D plus angle E, first of all we can look for all the angles of the triangle, then we can compare whether they are equal or not. Angle sum property. So D is 70, E is 80. So what is F here? Angle F becomes angle F is 180 minus 150, that is 30 degrees. So I am marking this angle as 30 degree, right? Here also in this triangle, in triangle PQR, angle P plus angle Q plus angle R is 180 degrees. Angle sum property, right? So two angles are given as angle P we don't know, angle Q is 80 degree, angle R is 30 degrees. This is 180. So angle P becomes 180 minus 80 and 30 is 110. So angle P is 70 degrees. Right? Now I am marking here angle P is 70 degrees. Right? Now we start comparing. In triangle DEF and triangle PQR, angle D is 70, here angle P is 70. Angle E is 80 degrees, here angle Q is 80 degrees. Finally, angle F is equal to angle R is equal to 30 degrees. Therefore, triangle DEF is similar to triangle D is equivalent to P, E is Q, F is R. So DEF is similar to PQR, and this is AAA similarity, right? So these were the different methods of similarities. Now the next question is, in the following figure, triangle ODC is similar to triangle OBA. It is given that triangle ODC is similar to triangle OBA. Now this thing I had told you, this is very important, because regarding this you can automatically equate the corresponding angles. Here it says O is equal to O. That means point O is equal to O. And D will automatically be equal to B. This D is equal to B. This B. So what we have to do is, angle BOC is 125 and CDO is 70. Find angle DOC, DCO and OAB. So what we have to do is, first we have to find the angles of triangle. This angle you can find with linear pair. See, angle DOC plus angle BOC is 180 degrees. Linear pair, right? DOC we can find, BOC is 125, this is 180. So angle DOC becomes 55 degrees. 180 degree minus 125, which is 55. Right? DOC is 55. Now in triangle COD, we can find this angle. This is 55. Now we can find this angle by angle sum property. In triangle COD, angle DOC plus angle ODC plus angle OCD is 180 degrees. Angle sum property of a triangle. So we have DOC as 55 degrees, ODC as 70 degrees, and OCD we have to find. This is 180. So angle OCD becomes 180 minus 125, which is 55. So again, this angle comes out to be 55, right? So we have found all the angles of one triangle. Now what we have to do is, we have to find angle CDO. CDO is 70, okay, fine. We had to find angle DOC. DOC was 50 degree, we have find. And DCO. DOC we have found, DCO we have found. DCO is equal to OCD, and lastly we have to find OAB. Now here we have to use the concept of similarity. ODC is similar to triangle OBA, right? So angle O is O, so this has to be 125. Though we don't have this, sorry. This is 55, this is vertically opposite angle, so this is 55. Now angle D should be equivalent to B. That means if this is 70, this has to be 70. And C is equivalent to A. We have to find OAB. This angle will be equal to this, because they are at the same place in a particular order. So C has to be equal to A. So we can say that angle OAB is equal to angle OCD, right? Corresponding angles of similar triangles. So OAB, angle OAB, this is equal to angle OCD, which is 55 degrees. So now we have found all the three angles that were required. Next question is diagonals AC and BD of a trapezium ABCD with AB parallel to DC. A, B, C, D with AB parallel to DC intersect at point O. Using a similarity criterion for two triangles, show that OA upon OC is equal to OB upon OD. Now see what is given to us. We are given that this is a trapezium in which AB is parallel to CD or DC. ABCD is a trapezium in which AB is parallel to DC, right? To prove that, we have to prove OA upon OC is equal to OB upon OD. So what is given here? These two lines are parallel. We have to prove OA upon OC is equal to OB upon OD. We have to use the similarity criterion, not by BPT. So what we can do is, here comes the proof part. In triangle OA and OC, OB and OD are occurring in the triangles AOB and DOC. In triangle AOB and triangle COD. What we can write here is, see these sides are parallel, so we can use the concept of alternate angles here because AB is parallel to DC. So what we can write is, let us mark these angles as 1 and 2. It becomes easier to represent them. Right? So see, this angle is forming an alternate angle here. Angle in triangle AOB it is angle 4. In DOC it is angle 3. They are alternate angles as AB is parallel to DC. Similarly, in AOB it is angle 1. They are in the position of Z. They are forming Z. So angle 1 is equal to angle 2, alternate angles. AB is parallel to DC. You always have to mention the angles as well as which pair is parallel for those angles. Here it is only one pair. So finally, angle AOB is equal to angle COD, vertically opposite angles. So I had told you earlier that even if you only write two pairs of angles equal, it is itself a similarity because the third angle automatically becomes equal with the help of angle sum property. So here triangle, if you write AOB here, the name of the triangle should be, see angle 1 is correspondingly equal to angle 2. So this point A is corresponding to point C. O is equal to O. See here. So at the place of O we write O. The D automatically comes here. And this is A similarity. Right? So by this, if we have to write the ratio of these sides, if you write the proper order, if it is correct, you can take ratio as AO, the first two letters here, first two letters here. So AO upon CO is equal to OB, second and third letter, second and third letter. It automatically comes out to be same ratio. You don't have to look for the proper letters. It is obviously equal to the same parts when we write them in a proper order. So AO upon CO is equal to OB upon OD. Right? These are the corresponding sides of similar triangles. Hence we have proved. Right? So the next question is, in this figure, QR upon QS is equal to QT upon PR. This is given. Given that QR upon QS is equal to QT upon PR and angle 1 is equal to angle 2. What we have to prove is triangle PQS similar to triangle TQR, right? So we have to check in which triangle we are getting this ratio, QR upon QS, QR upon QS, QT upon PR. Now this is out of the box. Instead, if it had been QP, we would have gotten the proper triangles. So that is what we have to look for, right? QR upon QS is here, and QT upon PR is given, and angle 1 is equal to angle 2. So we have to look for similarity in these conditions. Now we come to the proof part. Given that QR upon QS is equal to QT is equal to QT upon PR, right? This is given to us. Now, this is also given that angle 1 is equal to angle 2. And we know that if in a triangle, if the base angles are equal, then the corresponding opposite sides are also equal, so that it becomes an isosceles triangle. So if angle 1 is equal to angle 2, what sides can we equate? See, this is angle 1. Angle 2 is here, up to here. This and this. So look for equality in this triangle. PQR. Angle 2 is here. So this line is above angle 2. So from this we can say that PQ is equal to PR. The reason being, sides opposite to equal angles are equal. Angles are equal. So this becomes an equilateral triangle, right? So if PQ is equal to PR, that means we can replace here PR by PQ. So let this be 1 and let this be 2. Now using result of equation 2 in equation 1, it can be modified as QR upon QS is equal to QT upon, instead of PR, I am writing PQ, right? So now check this. Right? This has become QR upon QS is equal to QT upon PQ. Now you can see that these outer bigger sides are QR and QT are the sides of the bigger triangle TQR, and QS upon QP. This QS and QP are the sides of the smaller triangle PQS. And moreover, the included angle of both the triangles. Look for this triangle. The sides of this triangle, like PQ and QT of the bigger triangle, are in the same ratio. Now QS and QR of the bigger triangle are in the same ratio. Moreover, the vertical angle of both the triangles is same, angle 1. So angle 1 is equal to angle 1 common. So we can say that, therefore, triangle, what should be the name? See, Q is the letter which is common to both the triangles, right? From here, I had told you in case of this, Q is common. So Q is similar to triangle Q. Now what is that? Q is replaced by Q. So we have QR. R and S are equivalent. So if I write QR as QR and QT, what are the three letters being used here? QRT. Here it is QS and PQ. So we have QPS, the proper order Q and C. Q is replaced by Q here, R is replaced by S. So QS and P automatically comes here. QRT is equivalent to QSP. So we have triangle QRT similar to triangle QSP, and we required in this order, that means the same only. If we change the order here, like we required PQS. is similar to triangle. Here we have changed PQS, so we have TQR, right? So this is what we had to prove. And this is done by which similarity? This is SAS similarity, as we have used the ratio of two sides, pair of two sides, and the included angle. So it is SAS similarity. So the next question is, S and T are the points on the sides PR and QR of triangle PQR. So we have to make the figure first. PQR. S and T are points on the sides PR and QR. PR, S is here, S is here, such that angle P is equal to angle RTS, and T is here. So if we join this, it says S and T are points on the sides PR and QR of triangle PQR such that angle P is equal to angle RTS, right? So we have to prove triangle RPQ, the outer bigger triangle, RTS, the smaller triangle here, right? So given thing is triangle PQR, in which we can say that angle P is equal to angle RTS, angle RTS, right? So we have to prove that, triangle RPQ is similar to triangle RTS. So see, here we are not given any kind of sides or ratio of sides in this question. This is very easy question. So what we have to look for? We have to, only one angle is given to another, equal to another angle. We have to look for one more angle so that these two triangles become similar. So in triangle, I'm taking this whole triangle. What we have to prove? RPQ. In triangle RPQ and triangle RTS. I'm giving you one more hint. If it is given that you have to prove that these two triangles are similar, even if you're not able to locate any parts which are equal, see, we are given that angle P is equal to angle RTS. So you can check. P is equivalent to T here, right? So can we have angle R equal to angle R? See, if you mark this triangle as RTS, this angle R is appearing in this triangle RTS. Moreover, it is RPQ in the bigger triangle. So this angle is R is common to both the triangles. So we can write angle R is equal to angle R. Can we have it in Q and S? We are not given anything about Q and S, so that we cannot say. But even if we are given two equal angles in two triangles, we can say that they are similar. So angle R is equal to angle R, and angle P of triangle PQR is equal to angle RTS. This is given in the question, and this is common. So we can say that triangle, this is the proper order. RPQ is similar to triangle RTS. If you get confused, you can, if you have to prove these two triangles similar, look for the corresponding parts. You will get the idea or hint. How can you prove this similar? This is AAA similarity. Next is question 6. In the following figure, if triangle ABE is congruent to triangle ACD. Here it is given that triangle ABE is congruent to triangle ACD. You have to prove that triangle ADE is similar to triangle ABC, right? So this congruency actually gives you so many things that you can use to prove these two triangles similar. So if we start with the proof, what are we given? Triangle ABE is congruent to triangle ACD. Now, if you have learnt this congruency very well, you can say that corresponding parts are equal, as we are also using in the terms of ratio and angles and similarity. So AB here, if this is a proper order, the corresponding parts are equal. AB is equal to AC, right? BE is equal to CD. BE is equal to CD and AE is equal to AD. You can write this by default, AD, right? Now what we can do in triangle ADE and ABC, these are the letters which are useful to us. So what we can do is here AB upon AC. See, if we are looking for AB here and AC here, AD and AE, these are the sides which are common to what we have to prove similar. So I'm looking for the ratios because we are not concerned with equality and similarity. AB upon AC becomes 1. AE is equal to AD. AB, AC. So AD, here if we are keeping AB in the numerator, AB, then we can say here it is required AD upon AB. Okay, so AD upon AE is also equal to 1, right? So if these ratios are equal, we can write them as AB upon AC is equal to AD upon AE, right? I have just found the ratio of these two equal sides and these two equal sides, and now since the ratio of both these sides is equal, I have equated them. But since AB and AC are sides of the same triangle, they are not useful. What I can do is AB upon interchange these two parts. We had learned in this case of quadrilateral and trapezium questions. AB upon AD is equal to AC upon AE. Now check for these ratios. I'm erasing this. Then we have AB upon AD, right? Then we have AC upon AE. So you can see that the ratios of this smaller triangle sides, this bigger triangle side over this smaller triangle, this bigger side over this smaller triangle. And you can see that this angle, vertical angle, is common to both the triangles ADE as well as this whole ABC. So now you can write angle A is equal to angle A. So what we have done is we have taken the ratio of the corresponding sides of two triangles. Now how can we write the name of the triangle? It is triangle C. We can get the name of the triangle from these three letters. ABAC means triangle ABC is similar to triangle ADE. Now check for the corresponding parts. A is equal to A. D is equivalent to B. So if we have B, it should be D here. And finally it is E. This is what we had to prove. Triangle ADE is similar to triangle ABC by SAS similarity. Right? Next we have in this figure, these are the four parts that we have to prove. Okay, so the given thing is, this is the whole figure that we are given. The only thing is we have to keep in mind that AD and CE are perpendiculars on the sides BC. You can write here AD is perpendicular to whole BC and CE is perpendicular to whole AB, right? These are the four parts that we have to prove. So I'm starting with the first part. In triangle AEP and triangle CDP. Now look for those triangles. AEP AEP. This is, I'm marking this so that you can locate these two triangles, AEP and CDP, this small triangle above this. We have to prove them similar. So look for the corresponding. I'm telling you this is very easy question because here we have to just look for two equal angles in all the triangles. See, these are the two triangles. So these are the sides. You can simply say these are two vertically opposite angles, right? So what is the name angle in triangle? This is APE is equal to angle APE is equal to angle CPD. Why? They are vertically opposite angles. We have to look for one more angle. Tell me what is common. Here this is perpendicular. So this angle, if this is 90, this is also 90. And this angle is also 90. So we can write angle AEP is equal to angle AEP is equal to angle CDP, each 90 degree, right? It is given in the question. So we can say that triangle AEP, check for the order. What is AEP? See, E has to be equal to D. So E is there in the middle, keep D in the middle. Then P is equivalent to P because they are the corresponding parts. P is there, so C is there. AEP is similar to CDP by AAA similarity, right? For the second part, it is triangle in triangle ABD. ABD and triangle CBE. CBE. What we have to do? Now let me erase this. Now we mark those triangles ABD. ABD is this whole big triangle. ABD and CBE. CBE. This big triangle. Right? CBE is this. Right? Now look for the letters. I have told you if you get confused, you can mark those angles. What letters are common? See, B is equivalent to B. So we have one angle common. You can say that this angle B is common to both the triangles. So you can write angle ABD. Angle ABD is equal to angle CBE. This is common part. Okay, what else do we have? In triangle ABD, you can see that this angle is 90 degrees. In ABD, this is 90. And CBE, this angle is 90. So we have one pair of angles equal, like angle ADB is equal to angle CEB. CEB, they are equal, each 90 degree. Right? See, angle B is equal to angle B and angle D is 90, E is 90. Look for those parts. You will get your solution in clicks. So we have triangle ABD similar to triangle CBE by AAA similarity. Right? So now for the third part, triangle AEP. See, AEP is similar to triangle ADB. Triangle and triangle ADB. Now look for these things. AEP. This is the triangle AEP. Then ADB. ADB. This is a bigger triangle, right? So I had told you to look for the letters. Like A is equal to A. That we can see A is common. Then can we go for E and D? Yes. Angle D is 90 and in AEP this angle is 90. So we have got two angles equal. This can be very fast, like angle A, you can write the proper name, AEP. So angle PAE is equal to angle DAB in that case. You can write this as common. Now the next thing is angle AEP is equal to angle AEP is ADB. ADB, each 90 degree, right? Therefore, these triangles are similar. Triangle AEP is similar to triangle. Check for this. A is corresponding to A. E has been equal to D, ADB. This is also AAA similarity, right? So we have proved three parts. Now the last part is PDC equal to BEC, right? So the fourth part is in triangle PDC and triangle BEC. BEC. Now mark these figures. PDC is this small triangle, right? And BEC is this bigger triangle, right? This outer bigger triangle. Now look for the letters which are corresponding. C and C. C is common. CPD and BEC both have angle C as common. Now what else do we have in this? Angle D is 90 degree. In CPD it is 90 degree. And in BEC this E is 90 degree. Right? So here angle PDC. Angle PDC here is 90. And here we have angle CEB, which is each 90 degree, right? Next we have angle C, which is PCD is equal to angle ECB, common. Therefore, triangle PDC is similar to triangle BEC, right? This is also AAA similarity. So this is the easiest kind of similarity that we can have in similar triangles questions, right? Next is E is a point on the side AD produced of a parallelogram ABCD. So we have to make a parallelogram ABCD. A, B, C, D. BE intersects CD at F. So AD produced of parallelogram ABCD, we have to produce this. E is a point, right? And it is this. Now BE intersects CD at F. BE intersects CD at F, right? This is the side. BE intersects CD at F, show that triangle ABE is this bigger triangle CFB. So we have to look for ABE. This whole triangle is similar to this small triangle, right? So the given things are parallelogram ABCD. Parallelogram ABCD, in which we know that AB is parallel to CD and AD is parallel to BC. Also, E is produced. AD is produced to A. AD is produced to E, right? We have to prove that triangle ABE is similar to triangle CFB, right? So here also check if we can go for some sides ratio. I don't think so, because there is no sides given in any part of the figure. So what we have to look for, ABE and CFB, we have to look for, since this figure includes parallelogram, that means we can look for alternate angles or corresponding angles which can be proved equal. right? So what we can do, since opposite angles are equal, so if we take this triangle ABE, this angle A is equal to angle C of this smaller triangle because opposite angles of a parallelogram are equal. Okay, one angle has been proved equal. Look for one more. What it can be? These sides are parallel. These sides are parallel. So what we can do is, this is making a Z. So okay, this angle is equal to this angle. So in triangle ABE, and triangle BFC. See, when I'm writing the names of the triangles in the beginning, they may not be in the proper order. But after proving them similar, we have to maintain the proper order. So I'm not looking for the order in the beginning. Now, angle EAB. EAB is equal to angle BCF. BCF, opposite angles of a parallelogram are equal, right? Then the second thing is angle ABE. Angle ABE is equal to angle BFC. BFC. They are alternate angles as AB is parallel to DC. So now we have proved two angles of this triangle is equal to two angles of another triangle. Therefore, triangle ABE. See, I have told you A should be equal to C. So yes, A is equal to C. You can check for the corresponding parts from here also if you get confused. A is equal to C. Yes, they are, because they are opposite angles of a parallelogram. B has to be equal to F. So B and F are equal because they are alternate angles. So you can cross check this order. Now ABE is similar to triangle CFB. This is AAA similarity. So now the next question is, in the following figure, ABC and AMP are two triangles, right angled at B and M respectively. Prove that triangle ABC is similar to triangle AMP. So it is given that in triangle ABC, angle B is 90 degree. In triangle AMP, angle M is 90 degree. So what we have to prove is triangle ABC similar to triangle AMP. So for the first part, in triangle ABC and triangle AMP, see, we can mark the figures here. ABC is this triangle, right? And AMP is this triangle. So what we can do is, as even we are saying the names of these two triangles, we can see that angle A is common to both, right? So angle A is equal to angle A. It is common. What next we can do is, we can mark these. We are given that this angle in ABC, this is 90 degree. In AMP, it is 90 degree. So angle, we are given that angle B is 90. Here in B is equivalent to M, each 90 degree. So we can say that triangle ABC is similar to triangle AMP by AA similarity. AA similarity or AA similarity mean the same thing. So now we are done with the similarity part. Then we have to take the ratio. See, these are the sides of these triangles itself. So if this order is correct, we can simply write like AB. If we are taking two letters from here, first two, then next two, AM. Then write BC upon MP. You can write all the three. Then finally we have AC and AP in this order. Now what is required? AC and AP, this is required. BC and MP, this is required. You can exclude this. So we have AC upon AP is equal to BC upon MP. This is the second part that we have to prove. So we have proved both the parts. We have finished till question 9 from this exercise. The rest of the 6 questions we will do in the next video. I hope the similarity is clear to you. So hoping you liked watching this video. Please do not forget to like, subscribe and share this. Thank you.